is Jaemoon Kim. I'm from Korea. I work in the Samsung Electronics and in DMC R&D Center. In this center, I worked about video coding, and especially in this time to study and to prepare the implementation of the HEVC. This is my contents of my presentation. Actually, in the previous section, JR already explained about the HEVC briefly and status of this standardization. So we'll briefly skip the introduction of the HEVC. And I'll give some analysis and low delay coding of the HEVC. The low delay coding is very important to coding method for the low video surveillance or video telephony such as applications. So the HEVC is targeted to improve the coding efficiency compared to the H.264 at the high profile. This standard will be finalized at January 2013. This is briefly compared to the HEVC and the H.264. Their coding blocks are up to 64 by 64, and there's lots of partitions, including asymmetric partitions here. There are more directions in the interpolations and more complicated interpolation filter for the motion compensation. And there are large transform metrics for transform coding, and there are another post filter for named the SAO, sample length offset. So this is our weightless curve compared to H.264 and HEVC. This red line represents the RD curve of HM8.0, which is the latest test model of HEVC. And the black line represents the RD curve of H.264 high profile. It comes from the joint model like Jaehyun and 17.2. So as you can see here, they're at the same image quality. Their HEVC reduced the bit rate about half of the H.264. So in the HEVC, there are two coding methods. The first one is low delay coding, and the other is random access video coding. Low delay coding uses past frames as reference frames, but the random access coding uses past frame and also the future frame to interpolate the pictures. And HEVC supports generalized B and P coding, which is GPD, and allowing bi-precision at the low delay coding. The coding low delay coding, low delay B coding is better than that of low delay P coding, about 70%. However, there are some merits to use the LDP coding. For example, low delay P coding can save memory bandwidth and computation complexity. This is the required pixels for the low delay P coding and low delay B coding. The left side is low delay P coding. The current block is 8 by 8, and then the required pixels are up to 15 by 15 because the interpolation filter is up to 8 tabs. Moreover, in the low delay B coding, the current block requires two reference pixels, the list 0 and the list 1. So the required memory bandwidth is twice than that of low delay P coding. The memory bandwidth is very typical feature of the implementing a real-time video coding process. So reducing memory bandwidth is very important. So this is analysis of mode statistics. The left side is low delay B coding, and the right side is low delay P coding for the two sequences, Kiwon and BQ terrace. In this figure, there are more than 40% or 50% are coded with merge prediction, and sorry for the characters there. 8. This represents the 8 octave pair precision, which is the right side is the quarter pair precision. The low delay B coding can make the octave pair precision because the use interpolate linear interpolation of two quarter pair motion vectors. This is the motion vector distance from the low delay B coding. Just a moment. Sorry for the figure. The most of the motion vector difference is located from 1 to 4 or 5, which means the distance of motion vector L0 and L1 is very small, and since the motion vectors are very similar. So the proposed method is proposed method is guarantee the memory bandwidth as same as low delay P coding, which means in worst case the low delay B coding does not exceed this memory bandwidth that are low delay P coding. If we restrict the motion vector difference horizontally and vertically as less than 4, then the required reference pixels are the same as that of low delay P coding occurs. Since the HEVC uses 8-tech filter for use 2/4 sub-pair interpolation, and 7-tech filters are used for 1/4 or 3/4 sub-pair interpolation. So if we restrict the motion vector to motion vectors less than 4, then the required pixels are restricted to the same as the low delay P coding. Second method is restricted by predicted motion estimation. Motion estimation is very important tool in the video coding, and by predicted motion estimation is to find the best motion vector of at least L0 and L1, which means reduces minimize the distortion. So if we restrict the motion estimation by predicted motion estimation, there are little coding performance degradation, but the computation complexity is very reduced. This is the results of proposed method. The green graph represents the encoding time. This time is normalized to low delay P coding. The low delay B coding is about 1.5 than the low delay P coding, but the proposed method requires only 1.15 than the low delay P coding, which reduces computation complexity about 30%. The SAO is a sample oriented offset, is a kind of post filter, but if we off the SAO in the encoding, well, the coding gain gap of low delay B coding and low delay P coding is about 10%, is very large. But we in the proposed method, the coding gain is up to 6% than LDP coding, but the encoding time is about 70% of the low delay P coding. This is the article radius curve of several test sequences. The left side is the Kiwon and parsing, and the right side is basketball, second, and campus pictures, which is the class B sequences test sequences in the HEVC standardization. So this black line is the proposed method article, which is very similar to the low delay P coding. So in my work, we show that octa-pair precision motion vector is very important coding to increase the coding efficiency, and we reduce the computation complexity about 30% by removing precision motion estimation and using restricted merge candidates according to the motion vector difference. Thank you for your attention.
Other questions?
Yes.
Just have one question about the 1/8 pel motion vector accuracy, because according to my knowledge, we only have 1/4 pel motion vector accuracy.
Yeah.
Motion vectors in 1/4 pel. So how is it come that we're talking now about 1/8 pel?
As you see, standard adapted 1/4 motion vector precision, but in load-label decoding, the motion vector indicates the same single reference. Two motion vectors indicate the same single references. Then if the motion vector accuracy is 1/4 and 1/4, then the bilinear interpolation of these two motion vectors can be generated at 8 octa-pair precision. So it is recorded in the.
But you see that right there.
So it's an artificial aid.
Yeah, that's right.
Another question. Well, if this is not the case, thank you again. I especially thank all the authors who kept their presentations so short that we already